Swayam Prabha. Digital India. Educated India.
So, feedback Nash equilibrium is said to be of delayed commitment type if its appropriate restriction stage is a delayed commitment type. For the corresponding single act game. Okay, so obviously this tells you how much structure is needed before we even start analyzing, and even after you put in so much structure, okay, we can still get many different exotic equilibria and so on. And so for there we are therefore now looking for feedback Nash equilibria, and in that feedback Nash equilibrium you can further restrict and say, well, we will look for equilibria of delayed commitment type. Okay, so one of the main lessons that you see once you start looking at multi-act games is how complicated the strategic analysis can become, you know, even with a small number of stages. Like if you have 2 or 3 stages also, you know, the kind of variety that you can get, variety of outcomes that you can get is tremendous. Okay, let me draw one game and you tell me if this is in feedback form or not. So let's say this. Okay, so and now I'll draw the information sets. So is this in feedback form? You can't. I mean, this is not. You can see actually you cannot divide this into stages where each player is playing once, and yet have you know, information sets not going across stages. Okay, that's not possible. So this is not in feedback form. Not feedback form. It's not even stage wise form. Okay, if you so let's see, is this allowed? So player 1, player 2, not stage wise. So generally what we do is, this is again, as I said, it's a part of it's more of a modeling device. You specify the stages. Okay, you can, there are more than one way of specifying the stages, but you fix the stages first and then start drawing the information sets. That's a much more effective way of. Otherwise you could have of course there are more than one way of creating stages, and then you could have complications because of that. Not necessarily, not necessarily. Okay. Now here, let me see, say for example, suppose I take, so this is player 1, this is player 2 at this. Now here, suppose I have this, now is this okay? So this is stage wise, but it is not in feedback form, and that's because of this information set that I drew, which is going across two nodes which are in two different subtrees, right? So this is not allowed. So you can't do this. This is not in feedback form. Okay, but this kind of thing is not a problem. Okay, remember, there is no problem with having an information set like this, because it's part of one the single act game in that's starting from this particular node here. Okay. Likewise, this is also not a problem. See, player 2 is not the first acting player at this stage. So player 2 can have imperfect information at that. You can't similarly you can't have something like this, because then at this stage player 1 is confused about what had happened in the previous stage. Okay. Now it may be possible for you to do to play around with this in some way, by you could potentially, depending on the problem, you could potentially exchange these two. Make player 2 the first acting player in this, and player 1 first acting player there. But be careful, again, you can't violate the other requirement where player 1's information set should not go across two different branches of the first acting player, who is now player 2. Okay. So depending on the problem, you may or may not be able to do this. So just be aware.
What exact complication does the red circle avoid by not having it?
By not having it, well, you can't see this thing, right? If you so this, when we write for all this, effectively what we are saying is that regardless of what has happened in the previous stage, you should be able to get an equilibrium, which means that your strategy, the equilibrium here is what you are playing in every subtree is a function of what has happened along that subtree alone, and not across, and does not depend on the other parts of the subtree. So if you have an information set like this starts breaking down. So what would happen is, now how to play in this tree and how to play in this tree become coupled, and that in turn depends on what has happened in the previous stage, because you don't know what happened at the previous stage. I mean, at least player 2 does not know.
Physical possibility. It's just
No, it's not physical, it's more analytical, I would say. It's an analytical thing which we are trying to it just makes the analysis easier. Okay. Now again, the informational inferiority as a concept again extends, but here we talk of informational inferiority at each stage. Okay, you can't create information. You could, but again, it becomes way more complicated. You can't create informationally inferior games by putting information sets across across stages into one information set. Right? Then a player has forgotten which stage he is at, everything he forgets, and or he does not remember any of that. That is also an inferior game, but then results are much harder to prove for those kind of things. So we talk of informational inferiority at a stage-wise level. Okay, so you take the information sets, combine them at the stage-wise level, but still retain the feedback form and so on. Then you can potentially use the whatever results we had from before. Again, I mean, there is not once a game is multi-act game, without putting structure, we can't analyze much more. Okay, so this is pretty much all one can say sort of systematically. Otherwise, the only approach to finding all equilibria or for finding any equilibrium is to just write out the normal form, and then that's going to be a huge normal form with with vast number of strategies for each player. So we'll stop here, and so what we'll do in the next class is we'll go in a different direction and start talking about the use of randomness in a dynamic game. Okay, ways of randomizing in a dynamic game.